All right, so you need enzymes in a big way. There's lots of different kind of enzymes. Basically, so just in a few words, basically enzymes, who's timing me here?
I am.
We just restarted, so enzymes facilitate. What does facilitate mean? What is facile? It means easy. They make it easier. So they facilitate chemical reactions. Of course, we don't say it like that, do we? Facilitate. Chemical reactions in living things. In fact, it's true that there wouldn't be living things without enzymes. See, most chemical reactions go way too slow. Think about your body when you eat something and how fast everything has to happen in your cells. Things have to happen really fast. I mean, just me moving around here, those chemical reactions that are making me move around, they have to be happening really fast. We can't be sitting there like in a lab waiting for something to happen, right? It's got to be happening fast. So our bodies use enzymes to facilitate chemical reaction. Okay, just a couple examples. No, they have enzymes. I don't know why they move slower. Examples. Just some examples that you might be familiar with. There's an enzyme called lactase. All right? And it is actually sold over the counter as Lactaid. Trademark. That's a little trademark symbol up there or whatever. So Lactaid is sold down at CVS or Walgreens. What's it for? Good guesses. It has to do with digestion. Does anybody know Lactaid? Lactaid is for people who are lactose intolerant. Yeah, what lactase does is it breaks down lactose. Lactose, which is the sugar that's in milk. All right, we'll call this milk sugar. Milk is a little sweet, and this is the sugar that's in milk. Now, some people don't have, they're not very good at breaking it down in their body, so it causes digestive problems when they eat dairy products. Ice cream, milk, whatever. And this stuff, cheese, Lactaid, what you can do is you buy it, you take the pill when you're going to eat dairy, you eat it with the first spoonful, and then supposedly it works, and you don't have those problems, whatever it is, gassiness or whatever that comes from when you're not digesting it well. So lactase is one example. Another example, did you ever hear of Beano? Beano is a brand that you can buy. What's that?
So you don't flush.
Yeah, it's what you do is you eat it when you eat beans, and then it's supposed to reduce the gassiness that comes from beans. Well, why do you get gassy when you're eating beans? It's because you're not able to digest some of the compounds in them. Like, I think it's inulin, which is this starch-like compound that's in beans, and your body's not really made to digest that very well, and so it causes problems. So you take Beano, which is an enzyme that breaks down. I'm going to go out on a limb here and say it breaks down inulin. Which is a form of starch that we can't naturally break down, and that's in beans. So it's going to break things down. All right, now enzymes are part of a larger group called catalysts. Now, you've probably heard this word catalyst before. By the way, we had this little reading instruction thing yesterday in our PD, and they were talking about how we should talk to you guys more about how to read like scientific stuff, like science textbooks. And one of the keys, I think, for reading like your textbook or for even just taking science classes, you realize this. See how I just said enzymes are catalysts? We are always doing that in science. We're always defining things, categorizing things, talking about how one thing is connected to another. And so as you're listening to me or as you're reading your textbook, think about that. How does this fit in with that idea? In science, we're always categorizing and classifying. That's what I'm doing right here. Enzymes are classified as catalysts. Okay? Lactase, lactate and BNO are enzymes. Right? So we're just we're making different classes and categories and we're fitting everything into them. And that's a big part of biology. 4 macromolecules, right? Proteins, carbohydrates, lipids, nucleic acids. They're all polymers. You follow me? So we're just making all these groups, and it's a lot of vocabulary and a lot of groups, but just keep that in mind. That's the whole the style of science is classification. So enzymes are catalysts. Now you might have heard this word before too. Where? What's a catalyst? Oh, callus. No, not callus. Catalyst. How about catalytic converter?
It converts cats into...
Anybody ever heard of that? It's in a car. It's on the exhaust system, and what it does is it speeds up. A catalytic converter on a car speeds up certain reactions in the exhaust to get rid of some noxious components, like some toxic gases. Nitrogen oxides, things like that. Things that would make smog. It gets rid of them. But I guess what I was thinking about more is if you say that something is a catalyst, like a catalyst for change. Have you ever heard that term? Like somebody says that was a catalyst? It means it makes something happen. Okay? A catalyst speeds up reactions. So catalysts speed things up. They make things easier. They speed up reactions. They facilitate them. So just like you might say a certain person was a catalyst for change. Somebody can act like a catalyst. That's speaking metaphorically. That's using a metaphor. Yeah. Insulin, I'm not sure. It could be an enzyme. I'll have to look that up. I know it's a hormone. It's considered a hormone, but it could be an enzyme also. I'm not sure exactly how it works. If it breaks something down or puts 2 molecules together, then it would be an enzyme. If it makes molecules or breaks them down. So enzymes are considered catalysts. I have 3 minutes. Okay. The last part is, how do enzymes work? All right, well, here's what they do. Oh, first of all, I should add one thing, sorry. Enzymes are catalysts and proteins. Look at that. See this classification stuff? Now I'm putting them in another class. They're also made of proteins. Enzymes are proteins. So enzymes are catalysts that are made of protein. Enzymes are catalysts that are made of protein. All right? So how do they work? There's lots of different ways, okay? I'm just going to show some examples. There's lots of ways. I'm going to show the example in your book, and or actually, this is kind of a different example. Let's say we look at this is the enzyme. This is not how they all look, obviously. This is just one particular enzyme. And the enzyme, of course, is made of protein. And it has something on it called active sites. And these are parts of the enzyme where another molecule can fit in there, like a puzzle piece. Another molecule can fit into that site. Let's say we take a molecule like this, which is lactose. All right? Lactose is consisting of two sugars, glucose and galactose. All right? It's two sugars bonded together, glucose and galactose. What happens is this can fit right into this active site, like that. All right? And then the enzyme does something to it. Maybe it twists it or something like that, and the two sugars break apart. All right? Now that's just one way that enzymes can work. So the enzyme could be like a little machine, and here's what happens basically. The molecule fits in there, and it creates a chemical change in the enzyme, which then maybe twists and snaps the thing in pieces. All right? Now there's lots of actual ways that it might work. But in this way, it speeds up the breakdown of lactose. And it could speed it up by millions of times faster with the enzyme. All right? So that's just an introduction to enzymes. There's lots of different kinds. They do all sorts of different things, and if you read in your textbook, you'll find out more if you watch the videos online. Did I run out of time? I went over, didn't I? A minute and a half? Sorry.